Thank you for asking this question, for bringing this one up. Let me walk you through some of the parts to solving this. To start with, you need to be able to interpret this question. Whenever we're talking about a tangent line, of course, we know that we're going to use that the slope of the tangent line is the derivative, right? So we're going to find the derivative of f of x, and that derivative will be equal to the slope of the tangent line. We're looking for when the slope of the tangent line is horizontal, and horizontal, if you think of a horizontal line, here's an example of a horizontal line. Remember that the slope is 0, so we could interpret this as meaning find the derivative and then set that derivative to 0. And that's going to give us the solve for x, and that'll give us all the points where the tangent line to this graph is horizontal. Next, find all the points on the graph where the tangent line has a slope of negative 32. So for part B, it's going to be finding that first derivative, and then whatever we get for that derivative, we're going to set that equal to negative 3/2 and solve that for x. I started the work earlier so that this video would go a little bit more quickly. Feel free to pause the video if it's going too fast. To find the derivative, I'm going to use this f of x is 40. Instead of square root of x, I'm going to write it as x to the 1/2 minus 4x. And then I can apply the derivative of power, and that means 40 times 1/2 x to the 1/2 minus 1. So you see that over here. 40 times the exponent 1/2 times x to the 1/2 minus 1. 1 is also 2 over 2, right? And then the derivative of this one, you can possibly do it without thinking through what you're doing, but I'm going to go ahead and write out what I'm doing. I'm saying negative 4 times this implied exponent of 1. We've got this implied 1 minus 1, so that's going to give us x to the 0. Anything to the 0 is just 1, so that x just goes away, right? But you might look at this and just say, oh, the derivative of negative 4x is simply negative 4. So I'd get 40 times 1/2. Half of 40 is 20. X to the negative 1/2 minus 4. That negative 1/2 means that I write this x in the denominator as a square root of x. So we have 20 over the square root of x minus 4 for the derivative. For part A, I'm going to now set this derivative equal to 0 and solve. So I'd have 20 over the square root of x. Adding 4 to both sides, I'd have equals 4. And if I write that 4 as a 4 over 1, one way, and there's multiple ways, but one way I could solve this is cross multiply. So I have 4 square root of x equals 20 times 1. Square root of x is going to be 20 divided by 4. And then to undo that square root, remember what I'll do is say that that's squaring both sides. So the square root of x squared is just x, and x is going to equal 25. If x is 25, that means that x equals 25 is the only point where we get a horizontal tangent line. I do want to point out that there is a possibility that there could be more than one point, right? But for this one, there's only one x that solves this equation. We're not quite finished yet because the question says to find the point. X equals 25 is not a point. To find the y, we'd have to replace x with that 25. So if I do the square root of 25, that's 5, minus 4 times 25, so minus 100. 40 times 5 minus 100 will give us the y. So our point will be x equals 25, and then whatever we get for y down here. I'm going to leave that arithmetic part to you. Let's go on to part B. Find all the points where the slope is -3/2. Well, once again, we've got our derivative is equal to 20 over the square root of x minus 4. And if we're looking for when that is equal to -3/2, I'm going to solve for x when the 20 over the square root of x minus 4 is equal to -3/2. Once again, I could add 4 to both sides. It's just that the arithmetic gets a little bit trickier, right? 20 over the square root of x equals, now you could even, if the arithmetic, if this adding the fractions is what's holding you up, then you could even put this into a scientific calculator, right? Let me just review you really quickly with you how to do this without a scientific calculator. If I'm going to do -3/2 plus 4, I need a common denominator, so 4 is equivalent to 8 over 2. 4 times 2 is 8, over 1 times 2 is 2. So I could still do this without a calculator. I know some students say, but why bother? Well, make sure you still could do this if you needed to, though, right? For 5 squared, or not square, 5 over 2. And then we'll use the same process of cross multiplying. So 5 square root of x equals 2 times 20, divide by 5. 40 divided by 5 is 8. And I get that this square root of x is 8. How do you solve for x when we've got a square root? You square both sides. So the square root of x squared is x equals 8 squared, or 64. So I can write the point as 64. Oh, I still need another point, right? So don't quit once you do this hard part. This is the mistake that some students will make, is they just stop too early, or they assume that what they're doing is incorrect and don't finish. But this is the easy part. Y is f of 64. So replace the x with 64, and we'd have 20 over the square root of 64 minus 4, and that's going to give us our y part, our y point. Oh, wait, I'm sorry. I can't believe I just did that. Sorry. I need to go back to the original equation, right? This would be f prime of 64. We want f of 64. So f of 64 is going to be 40 square root of 64. So 40 times 8 minus 4 times 64. And we could put that into our calculator